Hi, good afternoon, everyone. First of all, I am going to give you a question today. You need to try that question, and then we will go ahead and move further with what we were doing. So, suppose that two firms are selling homogeneous products. They can charge high price or low price. You're given the payoff matrix of the firms, firm 1, firm 2. High, low, high, low. 8, 8, 3, 0, 10, 10, 3, 5, 5. You need to give me the answer to following questions. First, find Nash equilibrium of this game. Second, does it look like prisoner's dilemma? Why not? Huh? Third, is there any dominant strategy of this game? Explain. Okay. And fourth, suppose that firm 1 was first mover of this game. Find subgame perfect Nash equilibrium. Does it differ from the Nash equilibrium you found? You need to do these 4 parts. The weightage of the question is 20 marks. Do it in a proper way. Take 5-10 minutes. Try to solve this question first on your own. Then I will go ahead and I will answer this question for you. Try to answer this question. Okay, let's take this question together now. So, first of all, let's try to find the Nash equilibrium of the game. Try to see if you have also gone ahead and done it in the similar way. So, first part, Nash equilibrium. This is very simple. So I'm going to take high, low, and I have 8, 8, 3, 10, 10, 3, and 3, 5. So this is firm 1 and firm 2. When firm 1 goes for high, right? Okay, good. Let's see. So when firm 1 goes for high, what is the best response? Or you need to write this down, huh? This is a theoretical question. So what is the best response of firm 2 when firm 1 goes for high? Well, we need to compare 8 and 10, 10. So we can say low. What is the best response of firm 2 when firm 1 goes for low? You have to compare 3 and 5. So 5. So low. And I think this was 5 here, sorry. This was 5 here, right? Now, what is the best response of firm 1 when firm 2 goes for high? So you need to compare between 8 and 10. So low. And what is the best response of firm 1 when firm 2 goes for low? You need to compare between 3 and 5. So 5. Right? Now, when is a strategy Nash equilibrium? A strategy is called Nash equilibrium if the best response of firm firm 1 to strategy of firm 2 is S1 star, and the best response of firm 2 to strategy of firm 1 is S2 star. And when these two combine, you have star everywhere. माने जब firm 2 S2 star चले, you get S1 star here, and जब firm 1 S1 star चले, you get S2 star here. When they combine, then you can say that S1 star, S2 star is Nash equilibrium, right? So in this case, you have low here and you have low here. For strategy of firm 2, firm 1 का best response is low, and for strategy of firm 1, firm 2 का best response is low. Therefore, low is Nash equilibrium. Low becomes Nash equilibrium. That's the first part to this question. Okay. Now, the second part to this question will be pretty simple because we already know that is it like prisoner's dilemma? Yes. Part number B. So yes, the game is similar to prisoner's dilemma. Why? What was the property of prisoner's dilemma? The property of prisoner's dilemma was that there existed a strategy which was Pareto efficient, which was better. Pareto improvement is possible from Nash equilibrium, but we are not able to go ahead and go towards that strategy. है ना? तो अगर हम यहाँ देखें, if both firms follow the price of high, then both will get a higher payoff, right? But this is not coming out to be Nash. This is not coming out to be Nash. So why this is similar to prisoner's dilemma? क्यों है ये prisoner's dilemma? It is similar to prisoner's dilemma because there exists Pareto improvement over the existing strategy. Pareto improvement माने क्या? It means that both firms can attain higher payoff over the current Nash equilibrium. Both firms can attain a higher payoff. दोनों का payoff बढ़ सकता है. Both firms can attain a higher payoff over the current Nash equilibrium. That is why it is a prisoner's dilemma. Well, you should be very clear with the reasoning. Very, very clear with the reasoning part. Okay, now come to the third part. Is there any dominant strategy of this game? Yes. You see that whatever the other firm is doing, चाहे दूसरा firm high ले या low ले, this firm is always going for low. चाहे दूसरा firm high ले या low ले, this firm is always going for low. So each firm is not changing its strategy when the other firm is changing its strategy. Isn't that dominant strategy? So part number C. A dominant strategy is one in which player doesn't change its strategy. Player I doesn't change its strategy when player J changes its actions. Player J changes its action. Okay, in this case, we can go ahead and say that each firm goes for low price irrespective of the strategy followed by other firm. So no firm is changing their strategy. Both of them, they are going for low price irrespective of what strategy the other firm is following. So yes, we can go ahead and say that it is in fact a dominant strategy. Part number D. We need to present this game as a sequential game. Okay, we need to present this game as a sequential game, and we are already given that who is the first mover. Firm 1 is the first mover. So first of all, we are saying that here I have firm 1. Firm 1 is deciding between high and low. Then here we have firm 2. And firm 2 will decide between high and low, right? So then you can just write the payoff. High mein the payoff is 8. Firm 1 high, firm 2 low. Firm 1 high, firm 2 low. The payoff is 3,10. Firm 1 low, firm 2 high. Firm 1 low, firm 2 high. The payoff is 10,3. And last mein, low mein, the payoff is 5,5. Now you can find the subgames and find the Nash equilibrium of those subgames first. Subgame perfect Nash equilibrium. So here for this smaller subgame, firm 2 has to decide. So using backward induction. Here firm 2 has to decide. So between, this was 8,8. So between 8 and 10, firm 2 will go for this. Right? And here, between 3 and 5, firm 2 will go for 5, this. Right? So the payoff you will be picking up from here will be 3,10. And from here you will be picking up 5,5. Now firm 1 has to decide. So firm 1 has to decide between 3 and 5. So firm 1 will go for 5. Right? So how will you write subgame perfect Nash equilibrium? So you will say firm 1 goes for low. But you will mention subgame. In subgame, you will mention whatever happens with each node. So firm 1 goes for low, but firm 2 goes for low in both the cases. Had firm 1 chosen high also, then also firm 2 would have chosen low. So whenever you mention the strategies in subgame perfect Nash equilibrium, you mention what happens at each node, right? So the subgame perfect Nash equilibrium in this case will be low, comma, low, low. So this low is representing the strategy of firm 1 and this is firm 2 at each node. At each node, right? This is how you can go ahead and you can solve this kind of question. Okay. So suppose sometimes they will also ask this, that so here it does not differ. The solution does not differ. But if it differs, then they would have asked that, is there first mover advantage to firm 1? Then you would have compared the payoffs. You would have compared, acha, theek hai, in the simultaneous game, the payoff of firm 1, it is 5. Okay. And in this case, if in sequential game you were getting some other equilibrium, what's the payoff of firm 1? And is the payoff of firm 1 increasing or not? Right? And accordingly, you would have given your answer. So it depends on what payoffs are given to you in that particular question. But this is more or less the way that you can go ahead and solve this question. I hope that it's clear to you. Okay, let's go back.